Greetings, friends. I bet you're ready for another lesson on triangles. Yes, I know we've been through the parts of the triangle, and we've also found our three friends, the equilateral, isosceles, and scalene triangles. They're pretty fantastic, but you might have noticed that you have been finding, different kinds of these triangles as well. Slightly differently. Well, you might not quite be able to put your finger on it, but we're going to do that with this lesson. But what we're going to have to do first is get rid of our friends for a second, because we've actually got to head back to another lesson. It's why I brought these two sticks here, because when two lines intersect, they create an angle. It's true. And we've got different types of angles. Remember this right here, the magic triangle? That's right, we use it to measure right angles. So there's a fantastic right angle right there. But remember, there's angles that are also smaller than a right angle and larger than a right angle. Well, those ones that are larger than a right angle, we call an obtuse angle. And then the ones that are smaller than a right angle, that's right, pretty cute, right? An acute angle. So let's think about these angles as we look at these triangles. Let's take a look back at our equilateral triangle. Equilateral triangle. How fantastic. But for now, let's just call it triangle, because we're going to give it a different name in a second. I'm also going to bring my magic measuring triangle back, which tells me if I've got a right angle or not. Let's find out. This one here. That's right, you said acute, huh? Well, actually, it's an equilateral triangle. Everything's equal on it. If that one's acute, yep, that one's acute. Oh, this one's acute too. Well, hey, that means we have a new name for this triangle. It's an acute angle triangle. We also know it's equilateral, so we could call it an acute equilateral triangle. How really cute, right? Okay, let's move on to another one. Let's bring back that isosceles triangle. Here it is. And let's bring back its name too. Isosceles triangle. Well, let's see what kind of angles it has. Let's see. Well, that's acute. Okay. All right. That's acute as well. Less than a right angle, and they all seem to be acute angles. That makes this exactly an acute angle isosceles triangle. Wow, it has an even more insane name now, but it could also just be an acute triangle or just an isosceles triangle. But we like to have our names complete. Acute angle isosceles triangle sounds fine. Let's bring out another triangle. Hey, how about that scalene triangle? Right, scalene triangle. Let's take a look at this one. I'm actually going to measure this angle first. We've got an acute angle. Must be another acute angle triangle, huh? Let's measure this one, like going backwards this time. That's another acute angle. Nothing different this time, huh? Wait, what do I see there? By Jove, it's a right angle. This is a little bit of a different triangle. It is still a scalene, but we could call it a right angle scalene triangle. We could also just call it a right angle triangle if we want to just talk about angles, but why not have its entire name? The right angle scalene triangle. Pretty cool. But now I'd like to introduce you to some friends of these friends. Who should we see first? Isosceles, come on back out here, and where are your friends? Okay, all right. Whoa, you have some very interesting friends, isosceles triangle. Oh, another one over here. Wow, remember isosceles comes from iso and skelos. It means same legs, and all of these triangles have a pair of equivalent legs. Though they all do look very different, don't they? Wow, look at that one. Well, let's take a look at all these different angles. We know about this one already, so to clear space, let's move them to the side, and we'll take these two and also move them to the side for now. Let's focus on this one here. If I can even get this thing in anywhere here, yikes. What are we looking at here? Oh my gosh, I don't see, this is a very tough one. But it does appear to have 3 acute angles, and it is yeah, that's right, an isosceles triangle. So we have an acute angle isosceles triangle here. A very acute angle. Yikes. Okay, how about the opposite of that? This one right here. That can't possibly be an acute angle, could it? We can measure these 2 bottom angles near the base first. That seems to be acute. That seems to be acute. And then I have to flip this one over to find out. That is very far from acute, isn't it? That's pretty obtuse. This is a bit different. We've got an obtuse angle isosceles triangle here. Wow. You know, we had another friend here, another isosceles triangle. This one right here. Looks pretty nice. Let's try the angles in this one. Okay, cute. Everything seems to be in order so far. Another acute angle there. Fantastic. Okay. Now look, it looks like you've got one more angle. Would you mind if we, ooh, check that out. That's right. That's a right angle, which means that we've actually got a right angle isosceles triangle here. Who would have known? Well, just like the isosceles triangle has friends, the scalene triangle also has some friends. So here's our scalene triangle, and here's one of its friends, and we've got one other one too. Yes, these are all scalene triangles, but they do look different, don't they? Now, our original one that we measured had a nice right angle in it. We already know about that right angled scalene triangle, so let's find out what's going on with its friends. Well, let's see here. We do have another scalene triangle here. This one does appear to have a smaller angle here. That does not appear to be a right angle at all. Okay, let's measure the next. Also acute, and also acute. Wow, by Jove, we have an acute angle scalene triangle. Who would have known those could have existed? Okay, buddy, it's your turn. Wow, look at that lean. Okay, If I had sirens to go off, they would be going off right now. This is not a right or acute angle. Let's come back to that in a second. How about this one right here? Acute, that's right. Acute, okay, back to, oh my goodness, that one. It's pretty obtuse, isn't it? Yes. So this is an obtuse angled scalene triangle. So many different types of triangles, aren't there? Well, I have a mission for you. You've done a lot of good detective work in the past, and maybe you'd be up for another mission. All you'll need is a piece of graph paper, a straight edge or ruler, and a pencil. Okay, this is going to be a little bit interesting. We're going to create a triangle identification chart that will help us find the full names of any triangles we find. Now, go ahead and fold your graph paper in half. And if you don't have any graph paper, you can actually get some on the drive. It's there linked. And when you fold your graph paper, make sure you don't make the same mistake I did. Try to fold it on a line. I'm going to refold mine. And now that I've made that mistake, you won't have to. There, that's going to help us with dividing things up a little bit easier. Okay, go ahead and make a line right down the center where you folded. Right from the top to the bottom. Nice line of division. There we go. And then come down about 4 spaces and make a line, a horizontal line, right across the top. And then I want you to count out 3. So 1, 2, and 3. And put a line vertically down that 3rd line. Starting, I can actually come right down from the top. And the same on the other side. I'm going to count 1, 2, and 3 and make a line vertically from the top of the paper all the way to the bottom. And there we go. Fantastic. Now, your chart is pretty much done, except we sort of need to label some things. So right up here, I'm going to write sides. Sides, right? And then in this one, I'm going to write angles. Over on this side, I'm going to write object. And on this side, I'm going to write the word name. There's a closer view of what I've done at the top. Now, the next thing you're going to do is put some letters under here. So why don't you go ahead and just make one more line to keep those nice and closed in. So we have 3 different sides that we can have, or 3 different names of triangles by the sides. We have the equilateral triangles, so we'll put an E in that first box. We also have isosceles triangles, so we'll put an I, and of course, scalene triangles, so yes, an S. So E-I-S, equilateral, isosceles, scalene, and of course we'll go by angles in this next box. We've got right angle triangles, so an R. We have acute angle triangles, so an A. And we have obtuse angle triangles, so an O. This is a triangle name generator. It's going to give us the name of triangles. So I gotta go find some triangles, but I actually brought some that I found along with me. Yes, check this out. This is a child's tanagram puzzle, and it's got all sorts of triangles in it. Now, I definitely am gonna need my magic right angle to figure this out, but I'm also gonna need my ruler, right? So let's take a look. Let's measure these sides and see what we're getting. 5.5. 5.5, 8. 2 sides even and 1 side not even. That's an isosceles. I'm going to write the name of this, tanagram, and I'm going to check off the isosceles box. And I'm going to take a look at its angles. Well, there's a right angle, but how are the other 2 angles looking? Okay. Those 2 are acute. So I do have that right angle, so that would be a right angle isosceles triangle. Make sure to get the triangle part in there. Fantastic. Wow, that was pretty cool. But I know you're saying that was way too easy. Give us something a little bit more challenging. Well, I brought some other things here too. Check this out. It's an amaryllis ball, but if you look, there are some triangles here. If you use your imagination nicely, I'm going to try to actually make sure. Let's see, we've got almost an inch, nowhere near an inch, and wow, that one's very, very long, a bit longer than an inch. Hey, okay, amaryllis pod. 3 sides different. That's a scalene. Let's take a look at the angles in this one. This is very difficult, but that seems to be a bit bigger than an angle. Oh, that's definitely smaller than a right angle. That other one is so close, but I think it's obtuse. I'm not even sure. Let's see. That's pretty acute. Acute, obtuse. Oh, well, if we have the obtuse there, we know that this is an obtuse angle. Scalene triangle. I know that one was pushing it, but I've got some other things that I think that you're gonna like. Ooh, let's take a look. Oh my gosh. Yeah, that's right. There is a triangle right there. Let's take a look at that triangle. Got about 2.5 inches. We've got about 1.5 inches. Okay, and that last side is about 3 inches. So we could definitely say that that is a scalene triangle. Kitty's ear. All right, Kitty's ear is scalene. Let's see if Kitty's ear has angles in it. That is a bit obtuse. Looking at an acute there, because you know you can sort of get it by sight once you get a good handle on it. But measuring these are difficult. Okay, that's looking acute. So we've got an obtuse, acute, and acute. Obtuse angle. Scalene triangle for Kitty's ear. I've got one more fantastic example of a triangle, and you might have this one too. I'm interested to see if you do, and that would be, hey, it's my bead frame that I built with my own beads and string and all of that. But if you turn to the side, that's where it's pretty cool. There is a base and a triangle. All right, okay, so large bead frame, or as so many of you affectionately call it, the LBF. Let's get that in there. Okay. Looking at those sides, and you'll find that you'll really get a good eye for this as you go through this. I'll do centimeters this time. We've got 25, we've got 6, and we've got, I don't believe it, 25 and 25. That's an isosceles triangle. But now what about those angles? Okay, let's get that bottom angle there. It's pretty close to a right angle, but yeah, it's very close, but it does look, I know it's hard to see, it does look like it's slightly acute. And on the other side, slightly acute and definitely quite acute at the top there. We have an isosceles triangle with acute angles. That's an acute angle. Isosceles triangle. Congratulations, large bead frame. Gave us another type. Well, there's 4 crazy triangles I was able to find in my house, and I can't wait to see what kind of triangles you can identify from objects in yours. Have fun!